Welcome back to today's maths class. So we have already done few concepts of statistics. Let us now do some more concepts of it, which will be new to you, and I hope you all will be enjoying it with me. So let us start. Now we come to question number 2 of exercise 14.3. It says the following data on the number of girls to the nearest 10 per 1000 boys in the different sections of Indian society are given below. The table is section column. It is scheduled caste is 940, scheduled tribe 970, non-SC ST 920, backward districts 950, non-backward districts 920, rural 930 and urban 910. And they asked us to draw the bar graph. Here is our solution. Now along with the horizontal line we have written the section. So in the first one, first column SC, second column ST, third column non-SC ST, fourth column backward districts I have written here. The next one is non-backward district, next is rural and then is urban. I have plotted the points giving some gaps in between them. And according to the number given on the table, we have drawn the bar graphs. SC was given as 940. So the graph will be up to the length of 940 for SC. ST was 970. So the bar will be up to the length of 970 along with the vertical lines on the graph. And the third one non-SC ST up to the length 920, then backward up to the length 950, then non-backward 920, rural 930 and the urban is 910. Is it okay? Clear? Next is the question number 3 of exercise 14.3. The question is, given below are the seats won by different political parties in the polling outcome of a state assembly elections. The numbers are given in a tabular form. Then at the end it is asked, draw a bar graph to represent the polling results, and the second bit, which political party won the maximum number of seats. So here is the solution for question number 3. Now the party, along with the horizontal line we have drawn the political party, and along with the vertical line we have drawn the seats won. On top of A, the political party A, which has won the seats 75. So we have drawn the bar graph up to the mark 75. On top of political party B, which won the number of seats 55. So the bar diagram is up to the mark 55. Then the party C is up to the mark 37. Then party D is up to the mark 29. E is up to 10 and the last F is up to the mark 37. Now the question asks, which political party won the maximum number of seats? Now from the figure we can easily find out that the political party A has won the maximum number of seats, that is 75. Okay, is that okay? Clear to you? Okay students, now we come to question number 4 of exercise 14.3. Here we are supposed to draw a histogram on the table given to us. In the table, just check, the class interval is given as in the question as 118 to 126, next 127 to 135, then 136 to 144 and so on. And the frequencies are given here. They are 3, 5, 9, 12, 5, 4 and 2. But to draw the histogram, we cannot have a gap between the upper limit of the previous limit and the lower limit of the next class. To overcome that, we have to make them same. So in our new class interval, we are going to have the class as this. We had 118 minus 0.5 is going to give me the new lower limit as 117.5, and similarly the upper limit 0.5 will be added, so it will be 126.5. Next class, 127 minus 0.5 will give me 126.5 minus. Then the upper limit will be 135 plus 0.5, which is 135. Similarly, we do the same thing with all of them. The lower limits will be changed to minus 0.5 and the upper limit will be changed to plus 0.5. The frequencies are same. Now we draw the histogram. Along with the horizontal line, we take the class intervals, the new class intervals. So we mark them as 117.5, 126.5 and so on till the last one 180.5. Now since there is a gap between the width and this one, the first one is from 0 to 117.5 and the width everywhere is not equal to the width there. So we make a zigzag on this line. Now on the vertical line, we will be drawing the frequencies and we mark them accordingly. We have the lowest one 2 and the highest one 12. So we marked accordingly to adjust all of them. So I have marked them as 2, then 4, 6, 8, 10, 12, 14, 16 and so on. All of them of equal width. Now the first class interval is 117.5 to 126.5. On top of this, we are having the frequency 3. So on top of 117.5 to 126.5, we draw the bar up to the point 3 along with the vertical line. Now the next class interval 126.5 to 135.5, we have the frequency 5. So on top of this 126.5 to 135.5, we draw the bar up to the value 5 on the vertical line. Similarly, the next one we draw up to 9, next up to 12, then up to 5, then 4 and then 2. So this is our histogram for question number 4. I hope it is clear to you all. Now let us go for bit 2 and bit 3. Now bit 2 says, is there any other suitable graphical representation for the same data? Now the same one can be drawn as a bar diagram if we do not join the two endpoints, or in other words, if we do not change the class interval, then we can draw the same one as a bar diagram. So the answer is yes. Bit 3 says, is it correct to conclude that the maximum number of leaves are 153 millimeter long, and why? Now see here, the highest one is number 12. The frequency is 12 and this 12 is coming in the class 145 to 153. In the graph also you can check that this is the highest one. So we can say that the maximum number of leaves are of 153 millimeter, that is the upper one in this class interval, and this will be the tallest one. We can come to the conclusion that the highest one, that is 12, is in the limit 145 to 153, and since we are not including this 153, so we can come to the conclusion that the maximum number of leaves are not of 153 millimeter long. So students, let us discuss question number 5 of exercise 14.3. The question is, the following table gives the lifetimes of 400 neon lamps. We have in the first column lifetime in hours and in the second column number of lamps. The first column is the class interval, which is indicated as 300 to 400, then 400 to 500 and so on till the last one 900 to 1000. And in the second column we have number of lamps or frequency. They are 14, 56, 60, 86, 74, 62 and 48. The question asks, first bit, represent the given information with the help of a histogram, and second bit, how many lamps have a lifetime of more than 700 hours. So let us solve it now. So students, here is the solution of question number 5 of exercise 14.3. The question was as the class interval was also given to us and the frequency was also given to us, and we were asked to make a histogram out of that. So, here are the data, the class interval along the horizontal line and the frequency along the vertical line. The class interval starts from 300 to 400, then 400 to 500 until it is 1000. Now, since the width is not same, everywhere it is 100, but here it is 0 to 300. So, we make a zigzag line here and then we draw the histograms on top of each bar. So, from 300 to 400 our frequency was 14. So, we draw it up to the length of 14 along with the vertical line. Then in the next one we had 58. So, we draw along with the 58 on the vertical line, we make the bar and so on. So, this is our histogram A's. Now, in the second bit they asked how many lamps have a lifetime of more than 700 hours. Now, when we say it is more than 700, we include 700 to 800, 800 to 900, also 900 to 1000. Now, in the range 700 to 800, we were having the numbers 74 and then is 62, then is 48. So, the total number will be 74 plus 62 plus 48, which is coming as 184. So, we can say that total 184 lamps have a lifetime of more than 700 hours. I hope this is clear to you. So, students, let us discuss the question number 6 of exercise 14.3. The question says the following table gives the distribution of students of two sections according to the marks obtained by them. In the first column we have section A and in the second column we have section B. Now, inside section A we have two columns, one for marks, they are 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and the frequency of these class intervals are 3, 9, 17, 12, 9. Now, under the column section B, similarly we have two columns, one is marks, they are also 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50, and the frequency is 5, 19, 15, 10 and 1. The question says represent the marks of the students of both the sections on the same graph by two frequency polygons. From the two polygons, compare the performance of the two sections. So, let us solve it now. So, here is the solution of question number 6. Here we were having students of two sections, section A and section B. So, there will be two distribution table and two frequency polygon. Let us draw it on the same graph. Okay. This is the table for section A. The class intervals are as 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. Now, to draw the frequency polygon, we need to find out the class mark, which is the middle value of each class interval. So, the first one 0 to 10, the class mark will be 5, 10 to 20, class mark will be 15, 20 to 30, it will be 25, for 30 to 40, it will be 35 and for 40 to 50, it will be 45. And the frequencies are given as 3, 9, 17, 12 and 9. Now, we draw the frequency polygon for the section A. So, this is your graph. The class interval is on the horizontal line and the frequencies are on the vertical line. Now, the first on top of class mark 5, we have the frequency 3. So, on top of 5, the frequency is 3 here. On top of class mark 15, we have the frequency 9. So on top of 15 we have the frequency 9, then we have 17, then we have 12 and then it's 9, and then we join both the ends to the endpoints. That is first one with 0 and the last one with 50. The straight lines drawn in dark and bold color is for section A. Now let us come to the table for section B. Now for section B we have the same class interval. So in the similar manner we find the class mark as 5, 15, 25, 35 and 45. And the frequencies are given to us as 5, 19, 15, 10 and 1. Now let us draw the frequency polygon for section B. Now on top of 5 we have 5. So we mark it here. Frequency 5. Now on top of 15 we have the frequency 19. So on top of 15 we mark the frequency as 19. Then on top of 25 we have 15. Then 35 comes to 10. So here it is. Then the last one we have 1, which is here. And now we join all the points with the dotted lines. So this dotted line indicates the result of section B and the dark line indicates the result of section A. These are the two frequency polygons on the same graph. I hope this is clear to you all. Now let us do question number 7 of exercise 14.3. The question is, the runs scored by two teams A and B on the first 60 balls in a cricket match are given below. We have the number of balls as class interval of 1 to 6, then 7 to 12, 13 to 18, 19 to 24, 25 to 30 and so on till 55 to 60. And we have two more columns with the runs of team A and team B. That means in the first 1 to 6 balls, team A scored 2, team B scored 5. Then in the next 7 to 12 balls, team A scored 1, team B scored 6 and so on. Now at the end it is said that represent the data of both the teams on the same graph by frequency polygon. So let us draw it now. So students, here is the solution of question number 7 on the board. The class interval was given as 1 to 6, 7 to 12, 13 to 8 and so on. You must have noticed that there is a gap between the two rows. First one is 1 to 6 and the second one is starting from 7 instead of 6. So for that we have to make a new class interval for each one of them. So the new class interval is made in such a way that the gap between 6 and 7 is 1. So we add 0.5 on the upper limit and subtract 0.5 from the lower limit. So now the new class interval is 0.5 to 6.5, then 6.5 to 12.5, then 12.5 to 18.5 and so on. And the last one is 54.5 to 60.5. According to this, the class mark, that is the middle value, is as in between them the middle value is 3.5. The class mark for this is 9.5 and for 12.5 to 18.5 we have 15.5 and so on. We do the same manner for all the class intervals. Then we have the frequencies for team A and team B, which is already given in the question. Now let us see the frequency polygon of both the teams. Along with the horizontal line, we have the class mark pointed as 3.5, 9.5 and so on. And along with the vertical line, we have the frequency for both the teams. Now the first one we draw for team A, which is being drawn in the dark line. So you can see on top of 3.5 we have 2. So here we have marked 2. On top of 9.5 we have 1 and so on. On top of 15.5 we have 8. Then on top of 21.5 we have 9 and so on. and later on we join them all with the dark line. Now we come to team B. Here on top of 3.5 we have the frequency 5. So on top of 3.5 we mark the frequency at 5. On top of 9.5 we mark the frequency at 6 as was given to us. The next is 2 on top of 15.5. So here it is. Then next we are having 10, then 5 and so on. And this one, the line which is for team B, we join them by the dotted lines. So you can see here two frequency polygon on the same graph, the darker one with the team A and the dotted one for team B. So I hope it is clear to you all. Now let us discuss the question number 8, which says that a random survey of the number of children of various age groups playing in a park was found as follows. They were given the data to us in the form of a table. They are age in one column in years, which starts from 1 up to the 17, and in the second column we have the number of children, which is our frequency. They are also given as 5, 3, 6, 12, 9, 10, 4. And then they asked, draw a histogram to represent the data above. So let us solve it now. So here is the solution for question number 8 of exercise 14.3. Let us see now. We were given the ages of the children in this manner, that is 1 to 2, 2 to 3, 3 to 5, 5 to 7, 7 to 10, 10 to 15 and 15 to 17. And the frequencies are 5, 3, 6, 12, 9, 10 and 4. But notice one thing, the width in the class interval are not same. Here it is 1 to 2, so the width is 1, 2 to 3 is again 1, then we have 3 to 5, so width is 2, 5 to 7, width is 2, 7 to 10, it is 3, 10 to 15, it is 5, and again in 15 to 17, we have 2. Now to maintain the uniformity of the rectangles in the histogram, we will have to do some calculation, and the formula is frequency by width into 1, because we want all of them to be of the same size. So 5 by 1, 5 by 1 into 1 is 5, then 3 by 1 into 1 is 3, 6 by 2 into 1 is 3, 12 by 2 into 1 is 6, 9 by 3 into 1 is 3, 10 by 5 into 1 is 2 and 4 by 2 into 1 is 2. Now let us see the graph. So along the horizontal line we have written the ages of the children starting from 1 to the 17, and along with the vertical line we have drawn the frequency starting from 1 to 6. See, first column we are having 1 to 2, the rectangle will be of up to the length 5. So from 1 to 2 the rectangle is up to the length 5. Then in the next 2 to 3 it is up to the height of 3. So 2 to 3 it is up to the height 3. Then 3 to 5 again the height is 3. So from 3 to 5 it is 3. Please note the width is also different here, 3 to 5. Next is 5 to 7, the width is 6. So from 5 to 7 length of the rectangle is 6. Then 7 to 10 the length is 3. So again from 7 to 10 the length will be up to 3. Then 10 to 15 the length is up to 2. So from 10 to 15 the length is up to the 2 of the vertical line. Then in the last one 15 to 17 the length is up to 2. So again from 15 to 17 the length of the rectangle is 2. I hope this is clear to you now. Our next question is number 9, which says 100 surnames were randomly picked up from a local telephone directory and a frequency distribution of the number of letters in the English alphabet in the surnames was found as follows. We were given a table with the first column number of letters. They are 1 to 4, 4 to 6, 6 to 8, 8 to 12, 12 to 20, and in the second column we have number of surnames, and they are 6, 30, 44, 16 and 4. And then they asked, first bit, draw a histogram to depict the given information. Second bit, write the class interval in which the maximum number of surnames lie. Now let us solve it. So here is the solution of question number 9. Let us see the table first. We were given the class intervals, that is the number of letters. They are 1 to 4, 4 to 6, 6 to 8, 8 to 12 and 12 to 20. And the number of surnames, which is the frequency, was also given to us as 6, 30, 44, 16 and 4. But here also same thing, the width is not same. In the first class 1 to 4 width is 3, then 4 to 6 it is 2, 6 to 8 it is 2, 8 to 12 is 4 and 12 to 20 is 8. Now to maintain the equilibrium of the rectangles, what we do, we make it of the size 2 first, which is common in both, that is the lowest one. So we write 6 by 3 into 2, which is 4, then 30 by 2 into 2, which is 30, 44 by 2 into 2 is 44, 16 by 4 into 2, which is 8, and 4 by 8 into 2, which is 1. Now let us see the graph. Now along with the horizontal names, we have written the class interval, that is the number of letters, starting from 1 to the last one 20, and along with the vertical lines we have drawn the frequency. They are also starting from 5, 10, 15, 20, 25, 30, 35, 40, 45, so that we can adjust all of them. Now let us see. On the first class interval, that is from 1 to 4, our length of the rectangle is 4. So from 1 to 4 the length of the rectangle is 4. Then in the next class 4 to 6 the length of the rectangle is 30. So in this class 4 to 6 the length of the rectangle is up to the mark 30 on the vertical line. Next class 6 to 8 the length of the rectangle is 44. So on top of 6 and 8 we draw the rectangle up to the mark 44 along with the vertical line. Then next 8 to 12 we have 8. So from 8 to 12 the length of the rectangle is now 8. Then 12 to 20 we have the length as 1. So from 12 to 20 we are having a rectangle of length 1. So this is our histogram is. Now the second bit is asking, write the class interval in which the maximum number of surname is. So we can see it from the frequency column as well as from the graph, that in between 6 to 8 we have the maximum number of frequency, that is the maximum number of surnames. So the answer will be, the class interval is 6 to 8, where the maximum number of surname, that is 44, is. I hope this is clear to you all. So students, with this we come to the end of this class. We have done few sums of exercise 14.3. We have solved some questions of this exercise, also discussed some of the different aspects of the statistics. I hope you all have liked the class. So we will meet in the next class again. Thank you.